Okay, as promised, let's see how we can read the values from binomial and Poisson distribution. So let's say there are random variable x follows binomial distribution with, so let's say, as I say, you can use p or n in any components you like. As practice, for example, I put n beforehand. Let's say, for example, 6, and let's say 60%. So by this format, I mean n is here, p is here. Just I interchange the place so that you know sometimes they do that and interchange them. But for example, for normal distribution, we always use mean for the first component and uh, variance for the second one. But anyway, for this semester, I will exactly notify what I mean by that. So if you want to write the final answer, I mean for the binomial distribution, to say, okay, this is the binomial distribution, then specifically say that this is n, this is p, so that there's no misunderstanding. But generally, we should know that this probability is a probability. So it's a value between 0 and 1. So obviously, this is not a probability because this is the number of trials. Okay, so we ask you, for example, what's the probability of x less than equal 1? So in the previous examples, I showed you we should reach such a format when we have less than or equal format. That's why you can read it from the table. But how to read it from the table? Now you know that binomial distribution for our question, for example, is 6 and 60%. So in my table, I look for n equal to 6, and I find it here. And then I look for 60%, which is here. What's the intersection? The intersection happens to be in this place. Okay, so what's the probability of x less than equal 1? So I take a look. Here it is denoted by r, but not always this is the case. But anyway, just know it could be also denoted by x. So x less than equal 1, it means that you should look for this. So that's the intersection. The final answer should be 0.037. Okay, usually it needs practice because some students by mistake get the summation of these two. And when we have, for example, x equal to 1 and we are looking for this value, as I said, everything should be in format of less than or equal. So first change it to x less than equal 1, subtract it from x less than equal 0. Okay, so by that you can calculate x less than 1, then subtract it from 0.004. So 0.004, and you will find the final probability. Now, by changing the parameters, I mean n and p inside binomial distribution, obviously you should be able to find the final answer. Like if probability of success is 30%, then n is equal to 4. Then the questions that we are asking you with respect to x, and here denoted by r, can be easily found by finding the intersection. So all of these values that you can see here, there are probabilities between 0 and 1. So when we talk about 4 and 30%, it means that we are talking about this box, right? So you will find it here. And there are also some ways, like if instead of 60%, it is given us 40%. Now how to read from 60%? Because only this part of the table is given to you, and they are asking question about 40%. There are also ways to do that, but since you have the table in the exam, we don't need to go through them, because I will give you the complete table related to our questions. So you won't need to have such conversions in our final or midterm exam for this semester. What about Poisson distribution? For this one, as you can see, distribution to another, the tables could be different. And we should be careful how to read from each one of them. So for Poisson distribution, you know that there is only one parameter. Let's say lambda is equal to 2. Okay, when this is the case, then it means that lambda is equal to 2. I'm talking about this column only. I don't care about other ones anymore. So if I wanted to give you a table, I could give you even this column. But sometimes we can give you this table. We can give you even more tables for Poisson distribution. Let's say even for the numbers between 1 and 1.5, I could give you also more values here, right? For example, 1.2. And I will also teach you about approximations from the tables when we talk about normal distribution, because that one could be very useful. But for binomial and Poisson distribution, I will give you the accurate values anyways. And even in the future problems that you will deal with, you will have the accurate one. So it wouldn't be necessary for computer engineers to go through that much. But for normal distribution and T-student, for sure, I will tell you about how to approximate values from the table. But here, everything is ready for us. So now if I ask you questions from this table, like what's the probability of x less than equal 4? Now, you know that we should only check for this column because lambda is equal to 2. In the lecture also, we showed lambda as alpha. I usually don't prefer that because later you will see error and we will show it by alpha. So the level of significance will be shown by the same notation. That's why I usually use lambda instead of alpha. Anyways, so for this column, lambda is equal to 2. So we just show it in this column. And also x, we are asking for less than or equal 4. This is the correct format for cumulative. That's why I can easily find the final answer, which is 0.9473. But if it is, for example, this question, then you should change the format to less than equal and then read it from the table. We should be careful about that. Because some students, when we ask, for example, x equal to 4, they report this as the final answer, which is not correct because these two are not equal. And the tables we give you, all of them are cumulative for distributions. Okay, it doesn't matter. This is continuous, discrete. This is a normal distribution, binomial distribution. All of them will be in cumulative format. Okay, guys, I hope the tutorial for today was useful for you. If you have any questions, you can ask me in the office hour or you can send me an email and I will answer your email less than 48 hours for sure. See you guys.